Hey guys, welcome to Chapter 6 Part 2 video notes over speed, speed time graphs, and velocity. So let's get right into it. Speed is defined as the distance an object can travel over a period of time. Some examples of different speeds would be 35 miles per hour, 5 meters per second, or even 50 yards in 5 seconds. Okay, we should be pretty familiar with speeds, how to write them out, especially with miles per hour, since you're probably pretty used to that with just driving around with your parents or your friends or anything like that. So while traveling, you might not move at a constant speed. Okay, you could be speeding up, slowing down, coming to a stop, maybe at a stoplight or a stop sign, anything like that. All right, so an average speed involves the total distance traveled and the total amount of time that it takes to travel that distance. Okay, so when we're looking at average, we're looking at the whole thing. In order to calculate speed, we need to divide the distance traveled by the amount of time taken to travel that distance. So it's distance divided by time. We can write this out into an equation as speed is equal to distance over time, where we are dividing distance by time. Remember to use Mr. Miller's rules for math work. We should always be using his steps whenever we do any math in his class. So let's look at our example here. What was the average speed of a car that traveled 100 miles in 2 hours? So first let's write out our equation. Speed is equal to distance over time. And let's write out the parts or the information that we know. Okay, so distance, we can see that the amount of distance traveled was 100 miles. Time, it took 2 hours to travel those 100 miles. And then if we plug those into our equation for speed, we get that speed is equal to 100 miles over 2 hours. For our last step, we should divide 100 miles by 2 hours. And finally, we end up with an average speed of 50 miles per hour for our entire trip. So speed time graphs, okay, much like distance time graphs, speed time graphs can also be used to represent motion. Okay, it's very important that we do not confuse these two. We need to be very careful when we are looking at these graphs. That way we don't make that mistake. Okay, distance time graph looks at a change in position, while a speed time graph looks at a change in speed. All right, two completely different things. Make sure you're paying attention. On a speed time graph, time is graphed on the x-axis and speed is graphed on the y-axis. That's how you can tell the two apart. So straight horizontal lines on a speed time graph indicate constant speed. Our speed isn't going up or going down, not increasing or decreasing. We're staying at the same speed. Okay. Straight upwards lines indicate constant increasing speed, while straight downwards lines indicate constant decreasing speed. Okay, so first going upwards, we're increasing, and then if it's going downwards, we are decreasing. And if it's straight, we're going at a constant rate. Now, curving upwards lines indicate increasing speed that is not constant, while curving downwards lines indicate decreasing speed that is not constant. Same as on a distance time graph, if the line is curved, it is not constant. So at this point in your notes, you have a section there with 4 different graphs on it. There is one with a horizontal line showing that the speed is neither getting faster or slower. We're staying at the same constant speed. You have one that is going upwards, a straight upwards line, showing that we are increasing our speed at a constant rate. We have a downward straight line that shows we are decreasing speed at a constant rate. And we also have one that has a dotted line and a solid line. Okay, the dotted line and the solid line both reach the same speed. They're both the same height. But the dotted line got to that speed in a much shorter amount of time than the solid line did. Okay, and that means that the dotted line is accelerating faster than the solid line. Okay, so make sure we are referring back to those graphs to help us out later on in class. We're going to need those. So your last section is over velocity. Velocity is speed in a given direction. Okay, you have to have both speed and direction in order for it to be a velocity. If you just have 35 miles per hour, then that's just speed. And if you have just north, then that's just direction. But if you put the two together, 35 miles per hour north, then that gives us a velocity. It's more specific. Okay, so some examples of velocities include 55 miles per hour northeastern, 10 meters per second south, and 1,000 feet per second west. Okay, all of those are speeds with a direction added on to it. So those are all velocities. Alright, so if you have any questions, make sure you're asking myself or Mr. Miller in class. That way we can try to help you out and get things cleared up. As always, thanks for watching.